Good day, my wonderful viewers. Welcome you once again to our today's class. Today we'll be treating how to calculate the area of a sector. Okay. Now the question before us says the sector of 380 degrees is removed from a circle of radius 12 centimeter. What area of the circle is what left? Now I'm going to break this down by explaining what a sector is and how we can deduce the area of a sector before going into solving this. Now, having a circle of this nature, you know a circle is a plane shape and the area of a circle is what? Pi r squared. Okay? And the totality of all angles inside this very circle gives us 360 degrees. Okay? Now, if this is the center of this circle and I take a portion of this out, a portion of this very area, this very place altogether is known as what? A sector. And there are two sectors here. This very place you are seeing is called the minor sector. While this bigger portion, this bigger side is called the what? Major sector. So altogether we have the minor sector and the major sector. So this smaller portion of part that is cut off here is known as the minor, while this larger part is known as the what? Major sector. Now, there is an angle of inclination at the center here, okay, which tells us the degree of angle that has been taken off. Okay, that gives rise to this portion we are considering here. Okay, now since you know that total angle in a circle or at a point is 360 degrees. So the angle of this minor sector, will be what? This very word theta. Okay. Now, what will now be the angle of this major sector, this inner part here? What will be the angle here from here to here? The angle of minor sector. Now, angle of minor sector and angle of major. Angle of major sector will now be equal to what? Total angle we have in the circle is 360. That will be 360 degrees minus what? Theta. So that will give us the angle of this major what? Sector. Okay. Now, if the total angle is 360 and we are taking a fraction of that angle from the total area of this whole circle, so what is the area of that fraction that is taken out with respect to the angle that it corresponds? Okay. So the angle here is theta. Okay. All over theta angle, which is 360 degrees. Okay. So this is a fraction of the total angle in a circle. Now, the fraction of that angle we have taken from total angle in a circle, then we multiply the total area of that circle. Okay, so if we take this fraction out from total angle we have in a circle, okay, the remaining angle that is left now will correspond to the area of the other part. So in that case now, total area we have here is pi r squared. So if you multiply the fraction of that angle, which is theta over 360 by the area of the circle, which is pi r squared, that will give us the area of this sector. So area of sector is given as this, theta over 360 times pi r squared. So in a summary, the area of a sector is a fraction of the total area of a circle with respect to what the angle given, the angle of inclination on that very word sector. Are we together now? So, bearing this in mind now, and the knowledge we've gained here, now let's go and solve this very problem before us. Okay? So I'm going to show you it off. Now I'm going to sketch this very question. We are giving this a circle. Okay? Having this circle as it is, we are told that a portion of it from the center here, a portion of it having angle 80 degree has been cut off. Meaning that this portion that is 80 degrees, now what will now be the angle of this remaining part? Remember that this part is the what? Major sector. While this smaller part is the what? Minor sector, right? So what will be the angle at this very place? The angle here, which is theta. So our theta here will be equal to what? 360 degrees minus what? 80 degree. So if you subtract this 80 degree from this 360, we'll be left with what? 280 degree. Okay, so that will be the angle of the what? Major sector, and that is what we are told to find the area. Okay, so that means that we are taking off this part. This part is not part of what you are. So what you are considering is this inner what part. Okay, so if you add this, find the area of this inner part. Okay, what will be the area of this inner part now? A fraction of that angle is what? What we have as what? Area of the sector now. This sector we are having now theta all over 360 times total area of the circle, which is pi r naught squared. Okay, so from this diagram, we are told that the radius of this circle is what? 12 centimeters. So here should be 12 centimeters. Okay, so and we are taking our pi as 22/7. So substituting the parameter given to us here, we have that area of this sector will be equal to 280 degree all over 360 times 22/7 times our radius is what? 12 centimeters. So we are going to get that 12 centimeters times 12 centimeters. Okay. Now what do we do? Do they have any common factor in common? Yes, they do. So 10 is common here. That cancels out. Okay. Now 7 is also common. 7 in this set is 1. 7 in 28 we have what? 4, right? Now what is common again? 2. 2 here is 2. 2 in 36 is what? We have what? 18. Then 2 here, 2 in 18 is what? 9. So what are we left now? We are left with the product of 12 times 12. That gives us 144 centimeters squared, right? Then all over 9. So if you multiply the whole of this out, okay, and divide it by 9, that gives us total area of this very what? Sector, which is referred to as the major sector. So having the product of 22 and 144, that gives us 3,168 centimeters squared divided by what? 9. So if you divide that by 9, we'll be having this as 35.2 centimeters squared. 35.2 centimeters squared. And that is the area of this very what? Portion of the circle that is what? Left. And that is our final answer. So thank you so much for joining us on our today class. Do well to follow us and you get notified when our new video will be made available. Okay? Bye-bye.